Here we go. 5.5.58. Properties of log. We have to learn the properties of logs in order to use the properties to solve, right? So 5.4 is about properties of logs and equations, but we're going to break it into two parts. What are the properties, how we can use properties, and then use them, okay? So to begin with, we have, if we let A, B, and X be positive real numbers, such as A is not equal to, that's what I want to put in there, not equal to 1, and B cannot also be equal to 1. When you don't have a calculator to do alpha window 5, you can still calculate the value of the log that is not common log. Oh, yeah. Okay. I know you were concerned and worried about it, but we're going to model what to do. So, for example, if I had log A x, I can use common log or natural log to solve it. Okay. So it can be written as, I wrote common, I meant to write log. So it's the log of your argument divided by the log of the base.
Yeah, we have
Yes.
written right.
I know, I sped ahead yesterday and told you all. I know. You weren't here, Samuel.
I didn't know.
All right. So you also can use instead, if for whatever reason you want, natural log. Same rule, natural log of x divided by the natural log of A. Okay. Now, this is pointless to do, but this is one rule I gotta tell you. This works regardless whatever the base is. Okay. So your base can be anything, but if I can type in a base in the calculator, would I need to do change of base? No. So why is it mentioned to teach you this? I don't know, but here we go. So it also is equal to any base. Exactly, because if you can write any base in, there's no point. So that's why it's in blue, because I don't see why it's part of the notes and it makes me a little blue. Okay. But let's try it out. So I would like for you, without using alpha window 5, to calculate log base 8 of 20.
So are you telling us to do that because we can't, or because you just want us to do that?
Because you can. We just went over how to do it.
No,
Where were you at? Okay, so again, if I have a scientific calculator, not a graphing calculator, in order to calculate log base 8 of 20, I would put in log of 20 divided by log of 8, and it would give me what said value.
1.44.
You're upside down.
She just told me I was bad.
Oh my God.
This sounds like that.
Oh my God. We're not going down this route. All right, continuing. All right, we're going to learn the rest of our log properties. Okay, so properties. We have A does not equal 1 again, right? So your base is not 1. Got it? All right. Now, the first property is called our product property. Anyone want to take a stab at why it's called product? Multiply.
Oh.
Do we not see U times V?
Yes.
Yes. So this is called our product property. Okay. When we had two exponents being multiplied, what did we do to their powers? We add them. So when we have two arguments being multiplied, guess what we do to their logs? We add them. So it becomes log base A of U plus log base A of V.
You fit it on that line.
Very carefully. Okay, let's do an example. If we had log 2x using the product property, what can I write that as?
Log base.
If there's no log there, what's the log? What's the base? 10. So I don't have to worry about it. It's common log.
So log 2 plus log A.
There you go. That is how the product property works. Okay, number 2 got disheveled in the printing. So it's supposed to read log A U divided by V. But I don't know what happened there. Okay, so let's think about our exponents. When we are dividing exponents, what do we do to their powers?
Subtract.
Subtract. So when we are dividing arguments of a log, what do we do with their log?
Subtract.
Subtract. Y'all are so smart. This is called our quotient property. So it would be log base A of U minus log base A of V. Unlike product, quotient order matters, right? The order matters when it comes to quotient. The numerator has to be the first term and the denominator has to be the second term. Okay? Order matters with subtraction. So let's do a little quick example. Log base 2 of x divided by 4. What does that become?
Log base 2 of x minus log base 2 of 4.
Perfect. Bam. How do you feel about the quotient? Good? Doable? All right. Still with me? You ran away?
What?
All right. The last one is called our power. And it's not quite like exponent rules, okay? The power here in exponents, our power property, we multiplied, right? Okay, so essentially we are multiplying, but not multiplying how you think. What happens is if your argument has a power, that power can become your coefficient. So if the argument has a power, the power can become the coefficient. So it becomes n log base A. That's a weird A. It was weird. Log base A U. Okay. So really quick, if I had log 3x squared, how could I rewrite that?
2 log base of 3x.
Perfect. Did I say per? I don't know what I said.
Yes, there's no.
No.
All right. How do we feel about product quotient power?
Good.
Doable? All right. Let's throw them in together.
No.
All right. So, rewriting log expressions. I'm going to apologize. So your example to this was supposed to be at the bottom of the page where you have all that space and it somehow shuffled to the top. Okay. So you're going to actually work it underneath it. Okay.
Okay.
All right. Here we go. So we're going to talk about expanding. What does it mean to expand? So when you're expanding, means to use log properties. And the goal is to use log properties to create simple. I know how you feel about the word. Simple sums and differences. Sums and or differences. And products. Okay, that's our goal, is to use log properties to create simple sums and differences and products. So we're taking one log and turning it into multiples so that we can evaluate in parts. Does that make sense? All right. So what I was trying to tell you guys is that your paper, like your example, you see how, where'd it go? Is it not on there at all? Like oh yes, see how it says example 1?
Yeah.
It all got cut off. So example 1, we're going to do it at the bottom underneath this. Okay. I thought I was going crazy. But
I thought you meant like there was equations. Like
no, it didn't even print properly. I think when I'm converting from a Word document to a PDF, sometimes my, what do you call it? Texts get lost. But anyways, here we go. So our example is supposed to be natural log of x, y to the 4th divided by 2. Oh my gosh. Look at that. We got all three. We got our product, our quotient, and our power property happening all at once. Okay. All right. So when you're starting, you want to start working from the numerator, working your way down. If something is in the numerator, that means it is a product. Okay, and that you are adding. If it's in the denominator, that means that it's a quotient and you are subtracting. So in our numerator, we have x times y to the fourth. So that's going to be the natural log of x plus the natural log of y to the fourth. In our denominator, we have 2. So it's going to be this minus the natural log of 2. Okay. Then after you've expanded, you then apply your power property. The power property applies to which term only?
Y.
The y. So our final answer would be the natural log of x plus 4 natural log of y minus natural log of 2. Okay, what this enables you to do is that if someone tells you the value of y, I can simplify really quick, right? If someone tells you the value of x, I can simplify it really quick. It breaks it down so that it's in an easier format for me to evaluate.
That's it.
Okay, that is it.
Oh.
That's expanding.
Okay.
Yeah, seriously. Okay. All right. Now we're going to go the other way. It's called condensing.
Oh, cool.
Okay. So to condense, you use the properties to rewrite as a single log. Okay, when you're condensing, instead of going in the order of quotient, instead of going product, quotient, power, you're gonna go power, quotient, or product. Okay, so the first thing you want to do is check for your power property. Then you want to check, is it product or quotient? Okay. So our problem is we have 3 log x plus 4 log x minus 1. So the first thing you want to do is, can I apply the power rule to undo this? Yes, I can take my 3 and turn it into the power of x, take my 4 and turn it into the power of this binomial. So we have log x to the third plus log x minus 1 to the fourth. After you do that, you then ask yourself, is this product or quotient? It is product because it is an addition. So that means when I consolidate to 1 log, it's going to become x to the third times x minus 1 to the fourth. And that is your consolidation. Oh my gosh, perfect timing. Okay, we're not doing section 4, so you can cross that out. Okay, so this concludes our 5.48.
Andrew.